Hello student, how are you? Very warm good morning to you. What did we discuss yesterday? Yesterday we discussed about the strength of organic bases, and there we have learned factor affecting the strength of bases. There are 5 factors. Number 1, the availability of electron, availability of lone pair. Number 2, the electronegativity of B. Number 3, the structural effect of B. And number 4 is the stability of conjugate acid. And last one, 5th one, the nature of the solvent. So these are the factors. By considering these factors, we are trying to find out why some of the bases are stronger, why some of are weaker. So I think so far we have seen 2-3 application of this. Now let us move on to the next application, maybe as a third application. What is that third application? That amides are neutral in nature even though they contains NH2 group. Amides are neutral in nature even though they contains NH2 group. NH2 group explain. So what amides are neutral in nature even though they contain as a NH2 group. What we said regarding as a organic bases, those organic compound containing nitrogen atom are basic in nature, but there are some few exceptions are there. So among that few exceptions, this is amide is one of the exception. And as most of you might be knowing the general structure of the primary amide, right? This amide, we know that while answering you must remember the structure of the general structure or general formula of amides. And as we know that R C double bond O NH2 is known as a amides, where R maybe as a alkyl group are the amide. Now look at here the lone pair which is present on the nitrogen atom, and according to as a Lewis basis act as a Lewis basis, but here these lone pair are not available for the donation. It is involved in the delocalization. Why it involved in the delocalization? Let us look at here. This is the carbonyl group, and as we know that carbonyl group act as an electron withdrawing group, and therefore it pulls the electron density, this lone pair toward that oxygen atom, and therefore we are going to get as a this lone pair form the double bond oxygen negative charge on that oxygen atom, and we are going to get here RCO minus double bond NH2. And what will be the charge on that nitrogen atom? I am putting the positive charge. Why I am putting a positive charge on nitrogen atom? Do you know? Yes, there is a 2 hydrogen atom and 2 bonds, so total becomes as a 4 bond, and therefore positive charge should be on the nitrogen atom, and this lone pair is not available for the donation, and therefore it acting as a therefore amides are neutral in nature even though they contain as a NH2 group, right? There is a NH2 group, but they are not, they should show the basicity, but that is not showing basicity because that lone pair is not available for the donation. It is involved in the delocalization, or it is engaged in a delocalization, and therefore these amides are found to be neutral in nature even though they contain as a nitrogen. Now let us move on to the next application. Suppose we have another one, phthalamides are basic in nature. Let us see, here is a phthalamide. Phthalamide is acidic in nature. Acidic in nature. Phthalamide is acidic in nature. Phthalamide is acidic in nature. Explain now or justify your answer. And we know that phenol are acidic in nature. Similarly, here also we are going to explain why phthalamides is acidic in nature. Do you know the structure of phthalamide? As far as my experience is concerned, 50% of you are not knowing the structure of phthalamide, right? So 50%, I am not saying as a 95% or 80%, but most of you might be knowing as a structure of phthalamide. Let us see the structure while answering. So everything is depend in the organic chemistry, everything depend upon the structure of the organic compound. Once you know the structure of the organic compound, it's very easy to write the answer, because the answer only require one or two sentences in and that is sufficient. That gives the precise answer of that question. So now phthalamides, once you draw the structure, this is a benzene ring where attach here this N and H, then C double bond O, this one. This is the structure of phthalamide. Structure of phthalamide. This is the structure of phthalamide, and where there is one proton is there attached to nitrogen atom. Now here is a nitrogen atom. According to that, it should be basic in nature, but not. This is a acidic nature. Why? Just now I told you there are some exceptions are there. Amides are neutral in nature. Similarly, this is just like as amide. On both sides there are the two strong, what we can call it as two carbonyl groups are there. They strongly electron withdrawing groups are there, and therefore these lone pair are involved in the delocalization, and therefore we are going to get as this type of the delocalization here. CO minus double bond NH, positive charge here, C double bond O, this one. Now this negative charge again coming back, and then this positive charge get neutralized, and you are going to get the next structure will be this one, C double bond O, N H, lone pair here, C double bond O, then this one, again this lone pair moving this side forming double bond, negative charge over there, and you are going to get here another structure is this one, C double bond O, then N H, then double bond C O minus. Here negative charge, positive charge must be coming on the nitrogen atom. And now suppose if you use here, let me clean the board first. Now suppose this one phthalamide, I am writing here again the structure. Observe the structure carefully. C double bond O, then double bond O, N H. By using as a base, suppose OH minus will abstract the proton and form the conjugate base here. And now when conjugate base is formed there, C double bond O, then N minus charge over there, and this one double bond O. After pick-upping by pick-upping the proton, whatever carbanion is, whatever negative charge left on that nitrogen atom, this species is called as a conjugate base, right? And as I told you at the beginning lecture, if the conjugate base goes on, if conjugate base will stabilize, that acidity goes on increasing, and hence therefore this negative charge here forming double bond over there, negative charge, so that you are going to get as another here O minus double bond N, then this one, they again you can write ETC, and this conjugate base is well stabilized due to resonance effect, and therefore thalamide is acidic in nature, or thalamides are the acidic in nature. This is the explanation about this. This is the application number 4th one. I think the application number 5 will be, let us see here, application number 5. What is that? Now is the application number 5. And as we here, guanidine is the strongest base. Guanidine is the strongest base explained. Strongest base explained, right? Guanidine is the strongest base explained. Here, how do you explain this? And now I am sure now is more than 60%. Now I am 10% increasing, more than 60% of the student not knowing the structure of guanidine, right? So 40% student may be knowing the structure of this guanidine. And now, and while answering the question of organic, you must draw the structure of the here. While answering here, first draw the structure of guanidine. The structure of guanidine is this one. Here NH2, then double bond H2, double bond, or here we can draw the structure. First one, correct. Here is a H2N. This is a structure of guanidine. This is structure of guanidine, right? And now, and in the first step, what is happening? H plus, guanidine is a basic in nature. Now the lone pair which is present on the nitrogen atom will pick up the proton from here, and you are going to get here NH2, then H2N, double bond NH2. Now on this nitrogen atom there is a 4 bond, therefore positive charge comes on that nitrogen atom, and further this is become as a conjugate acid here. And at the beginning, while studying as a factor affecting the strength of basicity, during that time we have seen one of the factor which the that is the stability of the conjugate acid. This is a conjugate acid, and after that conjugate acid, as we know that this conjugate acid lone pair forming double bond here, and this double bond neutralizing this positive charge, and we are going to get here NH2, then H2N, here NH2 lone pair as it is. Now here positive charge comes on this nitrogen atom. Now again do the next thing, this lone pair again goes here neutralizing that positive charge, and we are going to get here NH2, then double bond NH2, positive charge comes here, then H2N. Now here what is happening, the lone pair which is present here, they form as a double bond here, and this double bond neutralizing this positive charge, and we are going to get the structure here NH2, then here NH2, then double bond H2N, means here the conjugate base is well stabilized. well stabilized due to resonance effect, and therefore guanidine is found to be the strongest base. I think with this we have learned the strength of bases with the suitable example or 4 application we have seen, not 4, I think 5th application we have learned so far, then 6th application maybe the next one, and then that is aliphatic aliphatic bases we have learned, and in the next lecture we will see the aromatic bases and the heterocyclic bases. So let us stop today here, remaining we will see the next time. Have a nice day. Thank you.